This is the video for lecture 9.2. Take out your chapter 9.2 note sheets, estimating a population mean. So we'll start off with that first question. What is the point estimate for a population mean mu? We talked about point estimates in the last lecture. Point estimate is the value of a statistic that estimates the value of a parameter. And so if we ask you to guess the average age or estimate the average age of everyone in the classroom, you would be giving us a point estimate. We talked about confidence intervals in the previous lecture, and that's where we're going with this lecture. And so the point estimate for the population mean is the sample mean. It is a point estimate for the population mean. So that's the first term that we need to recall. We already calculated this previously, but the best point estimate for a population mean is the sample mean. And we have a notation for that, X bar. Fix that ink there. And so we'll be talking about a sample mean, but more specifically, we'll be constructing confidence intervals around the sample mean. So let's go revisit the idea of calculating a point estimate for the population mean. Here are some data for the miles per gallon of a vehicle of a Ford Focus. And so you have a sample from 16 different cars. And so if we wanted to obtain the point estimate for the miles per gallon of the population of Ford Focus cars, we would just take the mean of this sample here. And so you recall the mean is going to be the sum of all these values. You add those up, it's going to be, I've done this number already, it's 588.8 divided by 16. And so in this specific example, miles per gallon, not per hour, but miles per gallon, we end up with 36.8 miles per gallon at PG. And so that's a point estimate. Now, if you had to kind of guess, if you bought a Ford Focus 2011 and you had to try to estimate how many miles per gallon you would get, 36.8 is probably not the answer. As you can see, no car here, but it will be some value near that. And so that's why constructing a confidence interval would be more appropriate at this point. Constructing a confidence interval, meaning that we would say we're 95% sure that the miles per gallon are going to be between these two values. And so we have to learn how to construct something like that. Before we construct a confidence interval, some conditions need to be met, similar to what we had in the constructing confidence intervals for proportions. And those conditions are, first, the sample data must come from a simple random sample or randomized experiment to make sure the data is not biased. Two, the sample size is small relative to the population, which means your sample needs to be less than 5% of the population. And the third condition, that the data come from populations is normally distributed. If not, then the sample size has to be large. When we say large, we've been talking about in class that n should be greater than 30. And so that's considered large in our cases here. And so to construct a confidence interval, we need formulas. And so what we're going to have is, when you're asked to construct a confidence interval, there are two values that you need. You need to calculate the lower bound, and then you need to calculate the upper bound. Confidence interval, remember, are two values. So and so on. If I ask you for a confidence interval, construct it, calculate it, you have to calculate two values. And those two values are the lower bound, which comes out to be the point estimate minus the margin of error, and then the point estimate plus the margin of error. And so that's what we're dealing with. You might have seen this notation in the previous lecture in 9.1. Ours was p hat plus e p hat. One was p hat plus e, and then the other one was p hat minus e. That was in chapter 9.1. So this case, we just replace it with that, with the x bar, which is the mean. And in the previous lecture, these had values. X bar is your point X estimate. Your E is then the value that needs to be calculated. And so we have a formula for that. And again, let me just write this out so you know. So your margin of error is going to always be your point estimate plus or minus your margin of error. And so you have to calculate it. So what we're missing here is our formula for E. What is the formula for E? And so there's a formula we use for that. The formula for E is going to be, it's a new symbol for us. It's like a Z value, but it's called the T value times the sample standard deviation divided by square root of n. This here we've seen before. So this is the important calculation that we have to come up with after we have the X bar. So it's a simple calculation. All we got to do is come up with these three values for the variable. Once you do that, then we're good. What we need to know in this case now is this T value right here. This T alpha is related to something called the T distribution. We don't have to fully understand it. We just have to learn how to calculate the T distribution value, or the T alpha. What does it represent? It represents the area in the right tail of the T distribution. And we're going to do that, if you look ahead in your notes, we're going to do that using a T calculator instead of the normal calculator. And so I'll show you how to do that. It's related to T distribution. You look in the book, you see graphs of that, but again, we don't go in depth in that. And so what we do need to know how to do for sure, though, is calculate these T values, these T alpha, or this T alpha over 2. And that all is going to be related to your alpha level, or the level of confidence that you want to create your confidence interval. And so let's do this example here. Find the T values such that the area under the T distribution to the right of the T value is 0.10, assuming 15 degrees of freedom. That's another new term that we're going to be throwing around. Degrees of freedom, T value, some new values for us. They're similar to a T value, similar to the Z value, but we're dealing with the sample mean. And so we have to use a different value. So first thing is find the area to the right, the T value, 0.10, assuming 15 degrees of freedom. That is, find T 0.10 with 15 degrees of freedom. And so where we're going to get that is StatCrunch, calculators T. And so the T 0.10 is equal to, and then this is where you're going to go to StatCrunch. You're going to go to calculators T value. You see it looks like a normal curve, which it is, but it has a slightly different shape. DF stands for degrees of freedom, 15, and here you're going to put 0.10, and then the greater than, because they want the area to the right, compute, and you get 1.34. And so that's the value that you would put here. Now what we just did here is an exercise that you have to know how to do so that we can then construct our confidence intervals for a sample mean. So the next video will be us actually calculating a confidence interval.